Okay. So yeah, you got it. Okay, I'm gonna make this safe. Okay. Like next slide. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, most merciful. Assalamu alaikum warahmatullahi wabarakatuh. May the peace and blessing of God Almighty be upon everybody, and good afternoon. My name is Stephen Pearce, and I'm the CEO of Pearce Sustainability Consulting Group. My background is in ESG and sustainability strategy, but over the past several years, my work has shifted to something much broader, understanding how intelligence, infrastructure, and resource systems are now converging. And that's really what I want to talk about today. When people talk about artificial intelligence today, they usually describe it as the most powerful technology ever created. But I wanted to offer a different perspective. AI is not just a technology. Next slide, please. So slide two. AI is infrastructure, and that distinction matters because infrastructure is not neutral. Infrastructure shapes economies. Infrastructure shapes societies. Infrastructure determines who has access, who has control, and who ultimately holds power. Electricity did that, the internet did that, and now AI is doing the same, doing it again, but at a scale and speed that we've never seen before. What we're building right now through AI systems, data centers, and digital architecture is not just innovation. It is the foundation of the next global system of power. And the question we need to ask is not just what can AI do, but where does it run, who controls it, and what does it cost economically, environmentally, and structurally? Now let's start with something most people don't fully see. AI feels invisible. It lives in our phones, our browsers, our workflows. It responds instantly, almost magically. But what powers that experience is anything but invisible. AI is invisible, but its infrastructure is not. Behind every model, every query, every automated decision, there is a massive physical system. There's data centers, power grids, cooling systems, water systems, and fiber networks. These are not abstract concepts. They are industrial scale facilities consuming real resources in real places affecting real communities. And these systems are scaling fast. We're seeing projections where global data center electricity consumption could more than double within just a few years, already approaching levels comparable to entire countries. And that's before what's coming next. There's generative AI at scale, autonomous systems, always-on infrastructure, and AI embedded into every workflow. This is not linear growth, it's exponential. Now here's something that is often overlooked. A large portion of that energy isn't used for computation, it's used for moving data. Every time information travels from your device to centralized cloud systems to back, energy is consumed, not just in processing, but in transmission at scale, across billions of interactions. So what we build is not just a computational system, we build a global data movement machine, and is incredibly resource intensive. Now, let's go one layer deeper. Next slide, please. Computation, so slide 4. Computation itself is becoming more demanding. Training large AI models require massive compute clusters, specialized hardware like GPUs, and extended processing times. And even after all the training, running these models still consumes significant energy at scale. So we have two compounding forces, increasing computational intensity and increasing data movement, both driving resource demand higher. Now layer on the physical realities. The first is with water. Data centers consume enormous amounts of water for cooling, often in regions already under stress. Land. They require large footprints in strategic locations, competing with other critical uses. I'm on slide 4. Yeah, you're way ahead. Energy grids. Already strained systems are now facing massive continuous loads from AI infrastructure, leading to instability risk, higher costs, and delays in broader electrification. So when we step back, something becomes clear. AI is not just a digital system, it is a resource system. It consumes energy, water, land, materials, and it produces emissions, heat, and infrastructure pressure. And this is where the conversation must change, because we just keep thinking about AI as just software. We miss the real cost and we miss the real risk. This is no longer just a technology conversation. It is environmental, infrastructural, economic, and increasingly geopolitical. And once you see it that way, you can't unsee it. AI is not just shaping the digital world, it is reshaping the physical one. Slide 5. At the same time, something else is happening. AI infrastructure becoming increasingly centralized. A relatively small number of companies now control the largest compute clusters and the most advanced models and the underlying infrastructure that powers AI globally. And this creates a structural reality. When infrastructure centralizes, power centralizes. Not just economic power, but informational power, operational power, strategic power. This affects governments, enterprises, communities, and individuals. Because if your systems depend on infrastructure that you don't control, then your capabilities are also dependent. And that introduces risk, and not just technical risk, but geopolitical risk, regulatory exposure, and systemic fragility. I'm still there. This is where the idea of local AI becomes incredibly important, and I want to expand how we think about it. Most conversations frame local AI as privacy, security, or maybe efficiency, but that's only part of the picture. Local AI is also about energy efficiency, reducing the need to constantly move data across networks, reducing redundant computation, and reducing strain on centralized systems. Infrastructure resilience. If systems are distributed, they are less vulnerable, less dependent on single points of failure, and more adaptable to local conditions. Cost control, reducing reliance on expansive centralized compute, aligning processing closer to where value is created. Sovereignty, and this is the most important, because sovereignty is just not political, it is also infrastructural. It is the ability to operate systems within your boundaries, under your own rules, aligned with your own priorities, and that applies at every level, from individuals, companies, cities, and nations. Slide 6. What we are seeing right now is the convergence of three systems: AI, energy, and infrastructure. These are no longer separate. They are becoming one integrated system because AI drives energy demand, energy availability constrains AI, and infrastructure connects and distributes both. Now add climate change, resource scarcity, supply chain volatility, and geopolitical competition, and this system becomes even more complex. What used to be a technical decision, now a strategic decision. Where you place, how you design systems, what infrastructure you invest in, these are no longer IT decisions. They are economic decisions, environmental decisions, and increasingly security decisions. Slide 7. Now I want to shift to something I've been working on. Across my work with governments, development programs, and enterprise systems, I kept seeing the same pattern. Organizations are reactive. They measure, they report, they respond, but after the problems emerge, they produce reports on emissions, water usage, and risk response. But by the time those reports are finished, the situation has already changed. The risk has evolved, and the window for prevention is often closed. That model worked when systems move slowly, when change was incremental and risks were localized, but that's no longer the world that we live in. Today's systems are interconnected, interdependent, and accelerating. AI is scaling rapidly. Climate impacts are intensifying. Infrastructure is more complex, and disruptions cascade faster than ever before. A drought becomes a supply shock, an energy constraint becomes a cost crisis, and a data center cluster strains and already stressed grid. And these are not just isolated problems, these are systemic interactions. And reactive models are not designed for systemic environments. And so I begin by asking a different question. What if we didn't just measure the past, but anticipated the future? What if sustainability wasn't just about reporting, but about predicting? Now, in my work across North Africa and the Middle East, in East Africa as well, I've seen firsthand how infrastructure constraints, energy, water, and stability directly shape what systems can operate. The reality changes how you think about AI. It's no longer abstract. It's physical, constrained, and strategic. That's what led me to develop, slide 8, my Predictive Sustainability Intelligence, or PSI. The goal is simple: move from reaction to prediction, from static reporting to dynamic awareness, from delayed response to proactive decision making. PSI integrates 4 key components: sustainability, infrastructure systems, geospatial intelligence, and artificial intelligence. Individually, these exist today, but together they reveal patterns we can't otherwise see. They allow us to understand not just what is happening, but what is likely to happen next. Slide 9. For example, instead of reporting on energy usage, you could model grid stress before failure. Instead of tracking water trends, you can anticipate scarcity before crisis. Instead of reacting to supply chain disruptions, you can identify pressure points before the cascade. And critically, you can begin to anticipate climate-driven instability, including economic and geopolitical impacts. Now, here's where this connects directly to what GLAM is building. PSI alone is powerful, but when combined with local AI, it becomes transformational, because now you're not analyzing systems from a distance. You're embedding intelligence directly into infrastructure, running models where the data is generated within systems you control on secure, accessible hardware. This creates a fundamental shift from centralized analysis to distributed intelligence, from delayed insight to real-time awareness, from passive reporting to active systems, because now these systems don't just analyze, they act in real time within controlled environments without relying on distant, centralized infrastructure that changes everything. But instead, but because instead of waiting for reports, you're identifying risks they emerge. Instead of reacting to disruption, you're getting it in advance. Instead of asking what happened, you're asking what's about to happen or what do we do about it. Slide 10. That is the shift from hindsight to foresight, from reporting to intelligence, from reaction to control. And in a world where systems are more complex, interconnected, and volatile than ever, that shift isn't just value. Slide 11. Now, this is the bigger pictures. So when we talk about unplugging Skynet, we're not just talking about disconnecting from the cloud. We're talking about redefining control, ownership, and responsibility. We're asking, where should intelligence live? Who should control it? And how should it interact with the systems we depend on? Because the future of AI is not just about capability, it's about structure. Slide 12. And I'll leave you with this. The question isn't how powerful AI becomes, it's who controls it, where it runs, and who it ultimately serves. Because if AI is the infrastructure of the future, then control of AI is control of the future.